We're going to talk about repeated nearest neighbor. So there's more work involved in this one than there was on what we did on Monday. So today's assignment is going to be shorter than Monday's, but we'll see how it goes. I know. I've been waiting for you to actually ask to get Monday's assignment. Okay.
I don't interrupt.
Okay. That's fine.
I probably won't do it anyways.
I know. I'm aware.
I'm bad. Oh.
I know how this goes, dude. Okay.
I'll end up doing it eventually. For like the third time you print it off.
Yeah.
Great. Okay. So let's say that we have a let's see, we did traveling salesman yesterday. I don't know, I've been watching a lot of the Simpsons because they've
Same the reruns. They're actually doing.
yeah they just finished their their 600 their every Simpsons ever marathon.
I was so happy because they were doing like the older reruns.
Yeah, well they did every Simpsons ever. They did episodes 1 through 600. So let's say that like we got Moe's Tavern. We got the Simpsons house. We got the
nuclear power plant.
yep the nuclear power plant. We got the house, or no, I already did house. We got the retirement home,
Trustees.
and then we got the school. And Homer has to walk between these, and it doesn't really matter where he starts. So like he's not starting at any one spot, but he wants to find the shortest circuit that would hit each of these. So from Moe's to the house is let's say 8 minutes. From Moe's to the nuclear power plant is 20 minutes. From Moe's to the retirement home is 12 minutes. And from Moe's to the school is 9 minutes.
From Moe's to school?
Yeah.
Yeah, he's gonna get a beer after stop.
So from the house to the house is nothing, because the house is the house. From the house to the nuclear power plant is 25 minutes. From the house to the retirement home is 14 minutes. And from the house to the school is 10 minutes. From the nuclear power plant to the nuclear power plant is nothing. From the nuclear power plant to the retirement home is, let's say, 30 minutes, yep. And from the nuclear power plant to the school is, we'll say, 40 minutes. From the retirement home to the retirement home is nothing. Retirement.
School's 45.
Sure, we'll say 45 minutes, why not? And then I don't need to do school because I already have school to the house, I already have school to the nuclear power plant, I already have school to the retirement home, and school to school would be nothing. So I'm done with my table here. Does that make sense?
Yeah.
So now, I'm going to create a weighted graph for this. Now when you're creating a weighted graph, it's important that you have enough space for everything to be spaced out so that you're not confused about which path goes with which number. So I've got 1, 2, 3, 4, 5 things, which means that when I graph this out, it's going to look like a pentagram, and you guys are all going to freak out when you graph it, and you're going to make the num shabai noises when you graph it, or whatever.
I only did that once, okay? You
Great.
can't tell me when it's really
No, you did that more than once.
I literally did it once.
So I got Moe's,
No.
I got the house.
Biggest shame.
I've been using the 5 things because it makes it less confusing. Retirement, and then I skipped over the nuclear power plant. And then I've got the school. So I'm going to give myself some space between each of these. Bless you. Now if I wanted to make this more complicated, I'd make it so that, bless you, I'd make it so that like maybe there isn't a path from Moe's to the house. So like maybe there wouldn't be a path there, but I haven't done that on any assignment yet, and I don't see myself doing that anytime in the future, but I could do that. Now, from Moe's to the house, I said by the thing is 8 minutes, so I'm going to draw my path, and I'm going to weight it as 8. I'm going to go from Moe's to the nuclear power plant, I'm going to draw my path, and I'm going to weight it as 20. Mose to the retirement, I'm going to draw my path and I'm going to weight it as 12. Yeah, if you need a ruler, they're over there in the drawer next to Mason, labeled rulers and string. And then from Mose to the school,
Yo, hold on.
9. Okay. So far I haven't done anything new so far, right? So far it's everything that we've done previously. So house to the nuclear power plant is 25. House to the retirement home is 14. And house to the school is 9. Then I've got nuclear to retirement home, which is 30. And I've got nuclear to school, which is 40. So the nuclear power plant is like on the outskirts of town.
Exactly.
And then I've got retirement home to school, which is 45. I know. Yep, nope,
Can I
super.
make an educating comment here?
Sure.
The top of the star is pointing upward, that way, that means your spirit, because the other 4 points mean the 4 elements, and maybe your spirit is the 5th one.
Okay.
So the star is pointing upward, you're toward God, if it's downward, it's toward the devil, and that's when you come. Fun fact for everyone.
Okay. Good to know.
Still can be good.
Thank you.
How do you know that?
From now on, from now on, I will use either 4 or 6 things.
Please don't. It'll make it harder.
Well, 4 things will make it easier.
4 would be amazing.
I think we should do 8.
Great. Okay. Anyway, so what we're gonna do here now, I no longer need the table, so I'm gonna move my camera up so that we don't have to see the table. Now, so what repeated nearest neighbor does, it doesn't matter where Homer starts. He just wants to find the shortest circuit that's going to include all of them. So it doesn't matter where he starts. He doesn't have to start at the house.
You'd
So
rather just start in those
it doesn't matter where he
and
starts.
stay in
I'm
those.
saying
Okay.
in real life.
Sure, absolutely.
Yeah.
Okay, but it doesn't matter where he starts. He just wants to find the shortest circuit that includes all of them and then goes back to where it starts. So what we're going to do is we're going to look at a circuit that starts and ends at Mose, starts and ends at the house, starts and ends at the retirement, starts and ends at the nuclear plant, and starts and ends at the school, and we're going to see which of those circuits is shortest. So we're going to...
It'll be a while.
Yeah, I know. This is a lot of work. I agree. We're going to have to... good. That's fine. You get to. Everybody should hate their math teacher. If you don't, there's something wrong with the world. So
There's plenty of things wrong with the world.
let's take a look at the circuit that starts and ends with Mose. Okay. So with Mose, we're going to go with the shortest path first. So which is the shortest path out of Mose? The one to the house?
House.
Okay. So the first path is going to be from Mose to the house, which is 8 minutes. Now, once you're at the house, you're not going to go back to Mose. You can either go to the school, which is 9, nuclear plant, which is 25, or retirement home, which is 14. So you're going to go to the school, which is 9. Once you're at the school, you're not going to go to Mose because you've already been there. You're not going to go to the house because you've already been there. You're either going to go to the retirement home or the nuclear plant. The retirement home is 45, nuclear plant's 40.
Oh, sorry, I was looking at the wrong thing.
So you're going to go to the nuclear plant, which is 40. Once you're at the nuclear plant, you can't go to the house, Mose, or school because you've already been there. So you have to go to the retirement home, which is 30. Now, once you're at the retirement home, you have to complete your circuit. So you're going to go back to Mose, which is 12 minutes. Now, that's your shortest circuit. So you're going to go 8 plus 9 plus 40 plus 30 plus 12. So I'm just going to add these up in the easiest way possible. 8 plus 12 is 20, 50, 90, so 99. So 99, and then this is the shortest circuit. Now I'm going to have to do that for the other 4 places. I'm going to do it for the house. Yeah, no, sure, a little bit of work.
Oh, no, that's not what you mean about.
Okay,
I was going to throw it in the bottom.
So for the house, I'm going to take the shortest path first, which is Mo's, school, nuclear power plant, or retirement home. So for the house, where am I going to go first? So Mo's, which is 8 minutes. Once I'm at, okay, quiet. Once I'm at Mo's, am I going to go to the retirement home, the nuclear power plant, or the school? School, which is 9 minutes. Once I'm at the school, I can't go to Mo's or the house because I've already been there. I either have to go to the retirement home or the nuclear power plant. So I'm going to go to the nuclear power plant, which is 40 minutes. And then I have to go to the school, which is 30. Wait. No, I already went to the school, so I have to go to the retirement home, sorry, which is 30. And then I have to go back to the house, which is 14. I'm going to add these up. So this is, let's see, 70, 87 plus 14. 97, 101. So these two paths are both circuits, but they take a different amount of time. So far, which of these circuits is shorter? Mo's. So right now, to visit all of the places, which circuit would Homer prefer?
Mo's because it's geometry.
Sure, yeah, no, that too, because it's Homer, but also because this one saves more time. So let's look at the retirement home path.
Also, we have to do it for each and every one.
Yeah, we have to do it for all 5. So for the retirement home path, he's got 14, 12, 45, and 30. So which one does he take first? To Mo's, which is 12. And then from Mo's, he can't go to the retirement home. He can either go home, which is 8, to the nuclear power plant, which is 20, or to school, which is 9. So he's going to go home, which is 8. Once he's home, he can either go, he can't go to Mo's because he's already been there. School is 9, nuclear power plant is 25, and he can't go to the retirement home because he's already been there. So where's he going to go? School, which is 9. Once he's at school, he can't go to Mo's, he's already been there. He can't go to the house, he's already been there. He can't go to the retirement home, he's already been there. So he has to go to the nuclear power plant, which is how much? Are you guys paying attention back there? Now he has to go back to the retirement home, which is another 30. So this is 70 plus 17 is 87, 99.
Yeah.
So this path is equal to the Mo's path. All right, now we have to do 2 more. We have to do nuclear and we have to do school. So the nuclear path. So he's got 30, 25, 20, and 20. Which one is less? So nuclear to Mo's, which is 20. And then from Mo's, he's got 8, 12, and 9. The house, which is 8. From the house, he's got 8 that he can't use. He's got 9, 25 he can't use, and then 14. So he's going to go to the school, which is 9. Once he's at the school, he can't go to Mo's. He's already been there, or the nuclear, or the house. So he's going to go to the retirement home, which is 45. Guys, quiet. And then he's going to go back to the nuclear, which is 30. So this is 50 plus 17 is 67 plus 45. So far this is the longest possible path.
So now we gotta go
So one more.
school.
Yeah, we got to check the circuit that begins and ends at school.
So from school, he's gonna go to Mo's.
So he's going to go Mo's first. So I mean the Mo's and the house path are the same. Let's just assume he goes to Mo's because it's Homer. So school to Mo's, and then from Mo's to the house. So 9, 8, and then to the retirement home. Guys. Hey, stop! From here to school. Or no, not to school, to the nuclear power plant.
Yes,
Okay, so looking at all the paths, There's 2 that are 99. There's 1 that's 112, and there's 2 that are 101. So which path is least efficient?
There's two that are 99.
Right. So those are most efficient. Which is least efficient? Right. The path that begins and ends at the nuclear power plant is the least efficient path. So which are the 2 most efficient paths? Moe's and the retirement home. Now, because it's Homer, it's going to be the Moe's path. Yeah, fine. But so these 2 paths are equal in their efficiency. So we're going to call these 2 the best paths. And we're going to call this one here the worst path. And then the 2 that are 101 minutes, these are equal. Kind of, sort of? All right. So this one is more work than what we did on Monday. So what we did on Monday, you were told where was the beginning and ending, and you just had to find the shortest path. Now you have to use each of these edges, or each of these vertices, and find the shortest path for each vertex, and then say which one of them is the best. Kind of, sort of?
Yeah.
All right. So let's take a look at today's assignment. Yep. All right. So here's what we're doing. So we're looking at Filbert, the traveling salesperson again. So you're going to need to use a separate sheet of paper, just like we did on Monday. So if you don't have a separate sheet of paper, you can grab one from me, or I have some in that paper holder over there by Mason. So if you don't have a separate sheet of paper, you can go grab one. It's going to be best if you space these out. If you try to like smoosh them all into this little space I've given you, you're going to have a bad time. It's not going to go well because you're not going to be able to read which path goes with which number. It's not good. So use a separate sheet of paper. Give yourself some room. If you try to smoosh it all together, it's not going to go well. So we've got 5 cities here. I'm going to spread them out. Yep. Sub-assignments are worth triple.
Would it still be worth triple since I wasn't here yesterday and I do it? Would that change anything?
I don't know. I'll have to think about it. See, Seattle, Dallas, LA, Atlanta, and Chicago. Stop. Do we need to do like a ruler etiquette lesson? No. No.
I wasn't doing anything though.
Okay. So the first thing you need to do is space out those 5 cities. We got Seattle, Dallas, Atlanta, Chicago, and LA. So this time, unlike on Monday's assignment, Filbert doesn't have a home city. He just needs to travel to Seattle, LA, Dallas, Chicago, and Atlanta. He needs to do it with the least cost possible. Doesn't matter where he starts. So he can start in Seattle, he can start in Dallas, LA, Atlanta, or Chicago.
I really have to go to the bathroom. There you go.
You can wait for Steven to get back.
Okay. I really have to go.
Okay, fill out your planner first, and then when Steven gets back, you can go. Okay, so Dallas to Seattle is 120. Dallas to Atlanta is 85. And Dallas to LA is 150. Dallas to Chicago is 165. Okay, Seattle to LA is 70. Seattle to Chicago is 50. And Seattle to Atlanta is 120. Cool. And then we got alright, so LA to Atlanta to Chicago is 75. Atlanta to LA is 170. And LA to Chicago is 100. Okay. So to do this, we need to do each city. Doesn't matter which city you start with. Let's say you want to start with Seattle, though.
Seattle or LA.
So Seattle, well, actually, Seattle, Chicago is only 50.
Oh, yeah.
So you'd go Seattle to Chicago, which is 50. So you got seven. You got 75 for Atlanta. So you go to Atlanta, which is 75. And then from Atlanta, you can't go back to Chicago or Seattle. So Dallas, which is 85. And then from Dallas, you can't go to Chicago or,
So Seattle.
well, you can't go back to Seattle yet because you guys still got to go to LA,
Oh, yeah, so LA.
which is 150. And now you can go back to Seattle, which is 70. And now you would add all these up.
Oh, it's pretty easy.
Yep.
Now, if you don't know if you've had all your cities, since there's 5 things on here, at the end you should have 6 because you begin and end at the same city. So you should count up your cities and you should have 1, 2, 3, 4, 5. And then going back to the same city, you should have 6. So you should have 1, 2, 3, 4, 5 airfares, but you should have 6 cities that you hit.
Here's the model.
Thanks. So add up your 5 airfares, and you should have 6 cities that are part of your circuit. So 50 plus 75 plus 85 plus 150 plus 70. So $430. So that's the Seattle circuit. How can we solve this problem?
I will find it.
Okay.
Well, yes.
Do you need me to kick it to you? You got it.
I got one guy.
Okay. So for the LA circuit, we begin in LA. And then we've got 70, 150, 175, 100. So we'll go to Seattle, which is $70. And then we'll go to Chicago, which is $50. And then we'll go to Atlanta, which is 75. And then we'll go to Dallas, which is 85. And then we'll go back to LA, which is 150.
You want us to do it on the
Yeah, I mean, just so you can have enough room to do your work and stuff.
Mm-hmm.
I think it's a good idea. Because I didn't give you a ton of room. So then let's try the Chi-Town loop. So Chicago to Seattle to LA. And then we can't use Seattle or Chicago. So yeah, Dallas. Sure. Is that better?
Yeah.
So Chicago, Seattle, Los Angeles, Dallas, and then to Atlanta. Dallas to Atlanta is 85. 1, 2, 3, 4, 5, and then back to LA, which is 170. 70 plus 150 plus 85 plus 170. So this one's 525. Let's try the ATL loop. Yeah, I just was sick yesterday. Still not feeling super great, but I'm here. Yeah. Not feeling super great, but I'm here.
Yeah, same.
Started at the bottom, now I'm here. So 75, 50, 70, 150. So a lot of these end up being the same. Yep. Did I miss something? For which one of these? Oh, should it? Okay. I am an imperfect person and I make mistakes. So then this should be 50 plus 70 plus 150 plus 85 plus 75. 430. So are they all 430 then? Alright. I did a bad job making this one then. And let's look at the Dallas loop. What?
Is every one of them 430?
Yeah, they are all 430.
I don't know. We'll find out.
I've done some of them.
I got 565
Okay.
on one of them.
I'm sorry, I got 470 and 445.
Well, I might have made a mistake here. Let's find out. I am an imperfect person. I make mistakes so many times a day. Okay. So Dallas to Atlanta to Chicago to Seattle to LA to Dallas. Dallas to Atlanta is 85. Atlanta to Chicago is 75. Chicago to Seattle is 50. Seattle to LA is 70. LA to Dallas is 150. No. Okay, so Becca, which one did you get that was? Which ones did you get that were different than 430?
When I started at Chicago and ended at Chicago, I got 470.
Okay.
And then the Atlanta one, I got 445.
Okay, so let me check those two then. So Atlanta. Mm-hmm.
Something's supposed to be 165 on the Chicago one.
Okay.
From Dallas to Chicago.
Dallas to Chicago. Okay.
Dallas to Chicago.
Well, this is it.
Right. I'm just looking. I'm checking to make sure I did it right. So, did I set it up right? Or maybe did I set it up wrong?
Mine went from Chicago to Seattle to LA, Atlanta, Dallas, and then back to Chicago.
So Chicago to Seattle, and then what was next?
LA, and
Okay.
Atlanta, and then Dallas, and then Chicago.
I would.
Oh, okay, okay. Chicago to Seattle to LA. That's the problem. This should be Atlanta. I don't know why I went to Dallas.
And then Dallas, and then to Chicago, and then that was 4-7.
Yeah, this should be Atlanta. And this should be Dallas. Okay, so I made a mistake. So this should be Chicago to Seattle is 50, Seattle to LA is 70, and then it should be,
LA to Atlanta.
no wait, LA to Atlanta is though 170, and LA to Dallas is 150.
So what was it?
Unless I'm wrong.
Really?
LA to Dallas is 150, and LA to, let me check,
Yeah, LA to Dallas 150.
and LA to Atlanta is 170. Yeah, this should be Dallas, and then Atlanta.
So it's 130.
Yep. Let's look at the Atlanta, unless I'm wrong. Let's look at the Atlanta one here. Atlanta to Chicago is 75, which is the least expensive of these. Chicago to Seattle is 50, which is the least expensive of those. Seattle to Los Angeles is 70, which is the least expensive of those that hasn't been used. LA to Dallas is 150, which is the least expensive of those that hasn't been used. And then Dallas to Atlanta has to be used. Yeah, they're all 430. Weird. I don't know why I did that. So the path with so your answer to number 2 would be that they're all the same weight, and then the least costly trip is 430. That's your answer to number 3.
What's our answer number 2?
They're all $430. That's weird. I don't know why it ended up being like that. Sorry.
Okay.
I'm just
Number,
for number 2,
how do we set it up?
or yeah, for you mean for the second set.
Like, yeah, for that.
So for the graph, you have 1, 2, 3, 4, 5, 6 instead of 5.
Yeah, so
So you're gonna have to do A, B, C, D, E, F. So set them up in roughly a circle. You can't connect A to A, but connect the line from A to B. And then what's the weight of the line from A to B? According to the table. What?
what'd you say?
What's the weight of the line from A to B according to the table?
44.
44.